We're jumping right into our sources today for this deep dive and looking at a stack of research that frames gold production not as this romantic treasure hunt, but honestly as a logistical nightmare.
Yeah, nightmare is definitely the right word.
The mission here is to trace the sheer monumental effort required to produce just a single piece of bullion. Because we aren't talking about stumbling over giant nuggets here.
No, not at all.
You're dealing with concentrations often as low as 1 single gram of gold per ton of rock.
Which is just, well, it's the ratio that frames the entire industry. You literally have to move a mountain to get a coin.
Right.
It's arguably one of the most resource-intensive industrial processes on the planet. I mean, the challenge isn't even really finding the gold. It's taking this geological anomaly deep in the crust and refining it into something usable.
And that starts with just brute force.
Right, extraction.
The sources outline two main paths depending on depth. If it's near the surface, you have open pit mining where they carve those massive terrace benches. But if the veins go deep, they blast tunnels underground.
But getting the rock out is actually the easy part.
Oh, for sure. Because once it's out, it usually just looks like gray rock.
Right, the gold is microscopic. So this kicks off the phase known as comminution.
Which is just a fancy word for crushing it.
Basically, yeah. But the scale is intense. They take these giant boulders, smash them down to gravel, and then dump that gravel into rotating mills filled with steel balls.
And the texture required here was the detail that really stood out to me. They aren't just making sand.
No, they have to go much finer.
Right. To liberate the gold particles trapped inside the rock matrix, the sources say they grind it into a wet slurry with the consistency of face powder.
Face powder. That is the exact level of liberation required.
So once you have this face powder slurry, you have to separate the metal from the waste.
And physics helps a little bit here. Gold is roughly 19 times heavier than water, so they use centrifugal concentrators to spin the heavy gold out.
But gravity only catches the coarse gold.
Exactly. For the microscopic stuff, they switch to chemistry, specifically cyanidation.
They use a dilute sodium cyanide solution, which literally dissolves the gold into a liquid state. The sources compare it to dissolving sugar in tea.
It's a great analogy.
But the recovery method, how you pull that liquid gold back out, is where I had my big aha moment. They use the carbon in pulp method.
Which is the standard for the industry.
But the carbon isn't just generic carbon. It is specifically activated carbon made from processed coconut shells.
Yeah, it turns out coconut shells have the perfect pore structure to absorb the gold. It's this amazing juxtaposition of massive industrial vats relying entirely on coconut husks.
And the sources briefly mentioned alternative methods too, right?
Yeah, electrowinning where gold plates onto steel wool, or the Merrill-Crowe process using zinc dust. But either way, you are left with a sludge.
A sludge that is definitely not jewelry ready.
Not even close. So they smelt it at over 1,064 degrees Celsius, and they add flux to bind the impurities into slag.
And even after all that intense heat, you still only get doré bars. That was a key distinction in the reading. Doré bars look like gold, but they're semi-pure, maybe 60 to 90%. If you want investment grade, the journey isn't over.
Not at all.
Yeah.
That is where refining comes in. If you just need standard purity, they use the Miller process, bubbling chlorine gas through the molten metal.
To reach about 99.5%.
Exactly. But if you're a central bank or you manufacture tech components, you need 4 nines. 99.99% purity.
Which requires the Wool-Will process.
Right, an electrolytic method that dissolves the gold again and reconstructs it, atom by atom, on a cathode. It's really the only way to get perfect purity.
So we've traced the journey from a literal ton of rock down to a single gram of perfect metal. But the sources point out the process doesn't technically end there.
No, you have the closure phase, which is a massive part of modern stewardship.
Right, dealing with the footprint.
You have tailings, that waste slurry we talked about, which need to be treated to neutralize the cyanide. The land has to be rehabilitated. You can't just walk away.
It really emphasizes the permanence of the industry. We spend all this energy extracting the metal, and then a huge amount of energy trying to erase the footprint we left behind.
It does raise a difficult question for you to consider.
Yeah. If the process requires such intense, decades-long rehabilitation to return a site to its natural state, does the cycle of gold production ever truly end?
Or does the responsibility just slowly fade away long after the mine is gone?
Definitely something to think about the next time you see a gold ring. Thanks for joining us on this deep dive.